channel. Welcome to Embedded Systems Practical 4. In this practical, we're going to be controlling a DC bulb, a DC fan using our Android phone. We are also going to be using a microcontroller here. This is LGT8F328 microcontroller, and then we also have our NPN transistor motor driver here. Then we also have a relay driver module, which are built. We have two channel relays here. You can use one of the relays for the bulb. So this practical, we will also be developing an Android app. We're going to be installing, after developing the Android app, we install it on the phone, and then we're going to write program for this bulb. Welcome to Embedded Systems Practical 4. In this first part of our practical, we're going to learn how to control a DC lamp, a DC fan, all powered from 12 volts, using our computer via the keyboard and from our Android phone via Bluetooth communication. Here are the materials needed. Number one, we have a personal computer with our Arduino IDE installed on Microsoft Visual Studio. I'm using 2012, and also Pro Tools software. Then we need a microcontroller board. You can use Arduino Nano, you can use Arduino Uno, but I'm using a LGT 8F328. Here is the board that I'm using. Here is the microcontroller board. Here you can see it. So you can see you can use Arduino Nano for it. So I'm having my LGT8 F328 microcontroller board. Any other microcontroller board will do. Then we need a breadboard. As you can see, I already have the breadboard here. Our breadboard. Then we need some LEDs. As you can see, we already have some LEDs set up already. We need a relay driver. We need a DC motor driver. We need 12 volt DC bulb. We need 12 volt DC fan. I'm going to need an Android phone. And then we need some push buttons. You can see some push buttons here. Let's take a look at the block diagram of our design. Here we have our Bluetooth module. You can have a look at you can see this, my Bluetooth module here. You can see it. It's Bluetooth. So you can see it. Any Bluetooth module will do. AC06, AC05, you can use it. Then we have our push button. This is a microcontroller. This is our computer. We need a DC power supply. That's 12 volt and 5 volts. Then DC motor driver, relay driver, your DC fan, your DC bulb. Now your Bluetooth is going to be connected to the microcontroller. Then your microcontroller will be connected to the computer via USB serial cable. Your push buttons will be connected to the microcontroller. All this, your DC motor driver will be connected to the microcontroller. Your relay driver will also be connected to the microcontroller. So here is the power supply. The microcontroller needs power, 5 volts to send to it, 5 volts to send to your Bluetooth module and your buttons. Also 5 volts. DC also need power. 12 volts will be going here because our DC fan and our DC bulb we are using is 12 volts. You understand? So let's take a look at the circuit diagram. Now, in the first part of the design, we don't need all this. We don't need all this. First thing what we only need: our microcontroller, our Bluetooth module, our buzzer, our push buttons, some LEDs. We are using LEDs because we are going to be writing the program, which is the most important thing. But the program, your software, the software that we are going to develop is called firmware. Firmware is software that resides in a hardware for the purpose of making a hardware functional. So our Arduino C program that we're writing, we're going to write the program using the LEDs. Now, this LED you are seeing here will be representing our DC bulb. This other LED will be representing our DC fan. You understand? So we'll be representing our DC fan. Then our board is going to be connected to our computer through the USB cable. Now, if you look at this, your Arduino Nano, your Arduino Uno have one serial port. That is your 0 and 1, those pins. That's why we don't use those pins when the board is connected to the computer. So then our Bluetooth interface is serial. So how do we do? We take these two pins. You can take any two pins and make them software serial. That is artificial serial pin. So pin 10 and pin 11. You understand? You can just, or if you go to the internet, others connect their Bluetooth module to their microcontroller using some sort of different ways. But for me, this is what I usually do. I just use 1K resistors, so that if my microcontroller is a 3.3 volt board, it also works. If it's a 5 volt board, because some pins on the Bluetooth module, the level is 3.3 volts. So doing this way for me is very safer. You understand? So I just use 1K resistor, just connect it this way. So just as I've said here, we don't need these parts of the circuit, and this we don't need it for now. We want to develop the code. So the only thing that we need is just the LED. We are using LEDs. If you write your program and it controls the LEDs the way you want, it means your program is going to control the relays at well. So for now, we don't need the bulbs and all those things. What you just need, the LEDs. Now look at this. I'm using the PWM pins, although I'm only using PWM on pin 5. That's for the fan, because we want to control the speed. You understand? So that pin must be a PWM pin. You understand? For this one, I'm using a relay here. I just only want to just turn it on and turn it off. So that's why I'm using a relay. I'm not going to be dimming the board. We're not going to do that. But for the fan there, we need this transistor motor driver. So as you can see, so that I can be able to use PWM signal. You can see this is PWM signal. So I can be able to use PWM signals to turn on the fan, increase the speed to the maximum, and then reduce the speed to the minimum, turn it off. So that's our aim. So our board now is going to be connected to the computer. From computer keyboard, we can issue commands to control this pin 5 and pin 6. Then from our Android phone, via Bluetooth communication, we can issue commands via a serial terminal program. You know, our Arduino IDE on our computer already has a serial terminal program. Our Android phone doesn't come with serial terminal program. So what you do is just go to Play Store and download the Bluetooth serial port. So when you download that, you can be able to do. So now we are setting this pin, our pin 10 here. We're going to use it as RX. Then our pin 11. We are using it as TX. So you can see this is how we wire it. You understand? So let's go to our board and do the connection. Then we'll come back. So here is our circuit. We have done the necessary connections. Just as I've said, we are using LEDs. You understand? We are using LEDs. Let's take a look at our circuit again from the beginning to the end very well, so that we understand what we want to do here. So here is our circuit. We have connected our Bluetooth module to our microcontroller. So this LED here is our DC fan, while this LED here is our DC bulb. Then this one is the LED connected to pin 13. We have our buzzer here connected. So for now, that's just the connection that we need. So let's proceed to our computer for the programming. Remember, we are using Arduino C programming language to write our program. So let's get to the computer. So our embedded systems practical 4A. Here we are going to do the programming part. I am using Microsoft Visual Studio with Arduino plugin installed, which is known as Visual Micro. Look at it here. If you don't have Microsoft Visual Studio, you can use our Arduino IDE, the one you know very well. Before we start, I am using LGT 8F328P. So this is the microcontroller I'm using. So make sure if you are using the same microcontroller I'm using, your board LGT 8F328, you can select this. But if you don't have this, if you are using Arduino Uno, you can select Uno, or if you are using Arduino Nano, you can select Nano. But if you are using the same type of board I'm using here, make sure you have installed the boards. Most of the boards you see there are installed. They are third-party boards. Now I've done a video tutorial on how to install all these boards. So if you are the same LGT I'm using here, select this, then come down to the tools, come down here, make sure your clock is 8 MHz. No, this board operates at 32 MHz, and we know the Arduino Uno and Nano and the Mega operates at 16 MHz. So selecting 8 MHz will make the code run at 16 MHz from experiment. So make sure you select 8 MHz. Don't go and select 16. If you select 16, the code it will still be running on higher frequency, and this is going to make you will see your code misbehave from experiment. So I select 8 MHz and the code works exactly the same way to work in the Arduino. But still, this board, the CPU is run faster than the Nano and the Uno and even the Mega. Understand? So come down to variant and make sure you select this. This is the version of there exists some version different. So this is one I'm using here. So if yours is this that looks like the Nano, you select this. Then still come back to tools again. I already have my board connected to my computer, which is on COM3. So if you are using the Arduino IDE, you can set it up this way. But for me, I'm using Microsoft Visual Studio. You understand? So if you are using Microsoft Visual Studio, make sure you select. You can see I've selected LGT 8F. Then come to Visual Micro here. Do the same thing you did in the Arduino IDE. Select your clock. This in there, your variant, also select that variant type, and then come down here, your serial port. Make sure you select the correct COM port. Now we are starting.
you see this is necessary, but it's not compulsory. So I decided to give my file name, which I call Bluetooth serial 12V DC bulb DC fan. You know, Arduino extension .ino, your name. If you are developing a program, you are the one developing, put your name, the date. Now today is Christmas Day. Today is 25. So put the date. Target, which of these microcontroller boards is your code going to run on? I'm using this board. It will also run on this. It will also run on this. You understand? Then give some short notes on Arduino C program to control a 12V DC fan and bulb via serial communication through the computer keyboard and Bluetooth using an Android phone. So, which is our aim of developing our program. So, first things first, we need to include libraries. So, I'm going to include some libraries. I love this library. So if you don't have this, go and download this. This is a C++ output streaming library. So that's why I love using it. No, if I'm using this library, I won't be using serial.println. I don't like using that. So I will show you how to make use of this library. You can just go online and just type this on Google to take you to a GitHub site where you download it, install it on your Arduino IDE. And then, although the library is not compulsory, you should have this. You can just be using your serial.println. You understand? Then we also have some other library. You know, we are going to be using what? Bluetooth. So, you know, our Arduino Nano, our Arduino Uno has one serial port. The same with the LG T8F328. The TX, the RX and TX 0 and 1, those pins is used by the USB serial. So we are going to set up software serial on our pin 10 and pin 11 of our board. So you need to have the software serial library. So you add this library, that's your software serial, and then you need to set up give a name to your serial port. Let me call it BT serial. So then your RX pin, which I'm using pin 10, and your TX pin, which I'm using pin 11. You understand? So this is your RX TX. So you can see. So now let's move. So what do we do now? Our IO, input output pins. You understand? Input output pins, we need to set them up. So I will start by doing this way, as defined. So we're going to start with our LED. No, we already set up pin 10 and 11 here already. So let's call the LED connected to pin 13. Let's call it LED 1, which is connected to pin 13. Then followed by our buzzer, which is on pin 9. Then followed by our DC fan. So our DC fan, which is on pin 5, that's the PWM pin. Then our DC bulb, which is on pin 6. Then we have our push buttons. Now I know our push buttons are input pins. So these ones we have here, they are output pins. You understand? Take note of that. So our push button, let me start the BTN, that's button bulb. So the button to turn on our bulb, that is on pin 2. Then our button for our fan. Our fan will be controlled by 2 buttons, plus and minus, up and down. So let's say fan up. So our fan up button, which is on the pin 3. Then let's our fan down, the button for controlling, reducing the speed down, that is on pin 4. Then we have one button that will control both the fan and the bulb. If you press the button to turn on both the fan and the bulb, you press it again to turn off. So let's call that one fan bulb, so which is on pin 7. So this is our, so this one controls, let's say this one will be LED indicator. Then this one will be our buzzer, because we want to make some beeping tones, some audible tones. Then this one is our the pin to control the 12-volt DC fan. So that's the pin that will control. Then this one, the pin to control our 12-volt DC bulb or your DC lamp. So these are your button, your push button, to control your DC bulb. That's the manual push buttons. Then we have your push button so that's a push button to increment and fan speed. So you can see, so that's what that one does. Then this one, push button to decrement. So you understand, so which is this, you can see. Then this one, which is this, so to increase the speed and decrease the speed. Then this one is push button to control DC bulb and fan. You understand? So we have set up our, now we're also going to create some variable, some string variable. So let's call this one serial data. Then we also have BT data. You understand? Then we're going to create an int variable. Now we are using PWM, so we say PWM var. And then we're going to create something like, let's say fan level. So we're going to use them now. So let's enable our pins, our IOs. So our pin mode, we're going to start with our LED one. So let's say this output. I'm gonna just make this and make So what do we have here? Server LED 1 output. Then our what do we have there? Our buzzer outputs. Then we have our what? Okay, our DC fan output. You understand? Now you can write this on separate lines like this. It's still gonna work the same thing. You can write them like all this, still the same thing. You may want to write them that way, any how you please. You understand? So it's still gonna work. Then we have our DC bulb outputs. We're going to also create some, we are using push button. How many push buttons do we have? We have 4. So they're going to be input pull up because we are is push button. So input pull up, input pull up, input pull up. So the first one we have a button. We already have the bulb button. Then we also have our BTN fan. BTN fan up. Then we also have our BTN fan down. Then we have BTN fan bulb. BTN fan bulb. So these are all our input pull up pins. We've set them up. So then next thing, now we initialize our serial ports. We have 2 serial ports now. Serial dots begin. So we have 2 serial ports. Set both of them our BT. So remember this, the name we give to our serial port. So we have 2 serial ports here. The physically connected serial port, while this one the wirelessly connected serial port, that's via the Bluetooth. So you can see. So now let's give a welcome message. Now instead of me to do this serial.print line, welcome to Bluetooth PC control DC fan and the bulb. If this is what we want to send message, so instead of me doing this, I'm not going to be using this serial.print. So I'm going to do it like this. So this is C++ syntax. So which I'm using because of this library. So you can see. So that's how I use that library. So this just send a welcome message. If you want to send this welcome message to both the physically connected port and that of the Bluetooth, I will just repeat this, of our Bluetooth. You can see. Now after setting this serial port, it is good to give a little delay for like, let me say 200 milliseconds before sending any, or let's say just 1 second. When you power the board boots. So it's good to always allow the board to boot up before sending this message. So let's move on. Now we're going to do something. We're going to add some functions. We're going to create some function. Now we are writing this code, everything from scratch. You understand? So be observant. So this is C programming. That's what we are doing. The version of C programming we are doing here is called Arduino C programming. So the programming language we are using is called Arduino C programming language. So take note of that. So we're going to create a function called. We're going to create a function that will be checking the serial port. No, we have 2 serial ports. We're checking the serial port. Let's call this one check serial. So it is what we're going to be calling our function, check serial. And then we're also going to create a function that is going to give reply concerning the output of our pins or the load, whatever we turn on the board. We want it to give a message, a feedback message to what that the bulb is on. So this is going to be a string function. It's going to return some values. So this one be a string. So let's call it what name are we going to give to it? Let's say reply status, or reply output, whatever name. Okay, let's just call it reply status of what? Of the load that we are controlling. What load are we controlling? Your fan and the bulb, they are your load, or the LED, whatever you are controlling, they are the load. So reply, let's call it reply load status, whether the load is on or the load is off. So it's going to be a string vary data type. So because it's going to be returning some value. So that was what we're going to call. Then lastly we're going to create a function again to display information to the wired and the wireless serial ports. So let's call it void show. So call this one void show. Now it's going to be something like this. Serial you can see. So it's going to send the status of the load we are operating. We'll do that also on the Bluetooth side. So you can see, print it to the serial monitor. So now on our void loop, we are going to be calling this function. So take note, we're calling this function from our void loop. So now here is where all our code is going to be centered on. You understand? Here our code is going to be where our code is going to center on. So so let's start right away. So we're going to start with if serial dot available. Oh, what am I writing here? If what? Okay. If serial dot available. So we should do what? If there is data in the serial port, what do? We receive the data. So where are we going to store it? Now this variable, we're using it for the No, when you connect your board to the computer, we're using this to read the data. That's communication between the board and the computer. While this one will be wirelessly Bluetooth communication between the board and your phone. So we're going to use this thing to store the information coming from command from the keyboard. So we're going to say serial data is equals to serial dot read. What am I doing here? BT data is equals to serial data dot read string until what? Until we see until we see the end of the line. So what does this command mean here? No, we are reading the whole of this thing as a string, so because our data type here is string. So now if you press, when you type something, you press enter, that enter that you are pressing is this. It's going to add it to the message, so that our microcontroller will be read until it reach the end of the message before it will carry out any action. So that was the meaning of this. Read string until you see this. You know that this is the end of the message, then can carry out the required action. So we're going to use this for debugging purpose. We're going to still tell our board to echo it back to send it back. If you receive the data, send it back to me. So back to the computer and also back to the Bluetooth. So what do? We say serial. We say serial data is equals to. So we do this. So you can see. So print the message to the serial terminal. Do that also on both ports, the wired and the Bluetooth. So you can see. So what we're going to do now, we're going to upload this portion, this part of the code that we are writing here now. We're going to upload it to our board, and then we're going to test our board. So click on this button. It's going to compile your program, then upload. I have some other serial monitor programs apart from that one from the Arduino IDE. You understand? Apart from the serial monitor on the Arduino IDE, we also have another serial program that I use. So one of them is this is Termites. I also use this also. So let's use the Arduino IDE serial monitor. So this Arduino IDE has an inbuilt serial monitor. Serial monitor is used to send message between to and fro. That's your board to computer, computer to your board. So let's open it. So we're going to type something here. Let's say hello. Yeah, you can see our board is giving us sending us what we send to the board. You understand? Sending us what to send to the board. So you can see this thing is working. Now each time you open this button, your board is going to reboot. So you see the welcoming message. So you can see our board is let's say 1 2 3, enter. So you can see, so our code is working very well. So let's progress. Now let's say we're going to use command 11 to turn on our DC bulb, 10 to turn on the DC bulb, 21 to turn on the DC fan, 20 to turn off the DC fan. So let's just do it like this. So if serial data is this 11, So what do? So we'll say digital write DC bulb high. So you can see, and once we do this, make sure we should call this function. You understand? Call this function reply status. So you can see. So let's copy this. This one will be, let's use 10 to turn the DC bulb off. You understand? So we use this to turn it off. So call this function. So what are we going to do in this function? So let's do something like this. Let's create a string variables here. Let's say db. This one is DC bulb. df. This one is a DC fan. So let's do this to check if the bulb is on or it is off. So we're going to do this. This is shorthand way. This is pure C programming I'm doing here. So this is how we're going to do it. Digital read. Want to check our DC bulb. If it is high, that means if it is on. So you can see, if it is on, we want our dB to be this. Let's say DC bulb. You're gonna give a sentence like this. So the sentence is going to display else our that's a DC you see it. So this is pure C programming. So then we're going to return, so you see, so this is going to return if the bulb is on. Now once you call this function, what this function does is that it will check the pins. If it is on, it's going to return the value, which is a string with DC bulb on or DC bulb off. Either it is on or it is off. So that's why each time you activate the pin, you call this function. So the function does what? To give reply. So let's do the one of let's go for the DC fan. Now for the DC fan, these are the, okay, let's do something here. Okay, for the DC fan, let's use 2-1. Something, we're going to do up something here. DC, you know, we are going to be using PWM. So we are going to be using PWM. We're not going to do it this way because we are going to be using PWM. So this is what we're going to do. Let's come back to the beginning here. Look at this. Take note of this. Take note of this. Now you see this fan level. We're going to be issuing command from our serial monitor like F0, F1, F2, F3, F4, F5, F6, F7, F8, F9, F10. That for the fan speed level. F0 means fan is will be off, and F10 it means that fan will be in the highest speed. So you can see. So F. So so you can see. So so or let's do something here. Okay, now let me change the command I'm going to be using here. I'll be adding alphabet instead of using values there. So I will just say let's say, since DC bulb, let's just B1, B0. So you see, if I use B1, turn on the bulb, B0, turn off the bulb. Okay, that's very good. So if I use F1, you can see if I use F1, it means that I have to turn on the bulb. Now there's something we're going to do here. I'm not going to be using digital rights here. Turn fan high. I'm not going to do that. So this is what I'm going to do. So look at this fan level. Okay, so that's our fan level. We're going to be 1. You understand? Then so we'll create a function here. You understand? PW, I'll undo the PWM of the fan. So let's call this void void fan PWM. So you can see. So what this function will do is that now from our serial monitor we are using F0, F1, F2, F3 to F10, which we are going to map to fan level 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. So this is what we're going to do. Our let's say our PWM val will be equals to map. So what are we mapping? Our fan level. So the level is from 0 to 10. You understand? 0 to 10. So 0 to 10. Now you know that our PWM values is from 0 to 255. PWM, you are dealing with PWM 0 to 255. So 0 to 55. You understand? So now we can now apply the PWM on the fan by issuing this way: analog right our DC fan. What are we writing? Our PWM val. So you see, so that's how we're going to do that. So we will now call so you can see. So each time we issue F1 from our serial, fan level is going to be 0. So you can see. So now let me rearrange this so that it will be on the straight line. Make this look. Now remember, we're also going to be calling reply load status. Okay, yeah. Then let us also call this function show. Don't forget that. Okay. And the simple thing we'll do, we don't even need to be calling this function. We don't even need to call this. This is one we're going to call. Because this function is one that is calling this. So what we just simply do, just put that here. So each time you activate a pin there, so you can see. So if I send B1 to turn on the DC bulb, to call this show will print this. If it is bulb is on, you're going to print it. So you can see. So I'm seeing there. So now let me arrange this also very well. Now I'm going to start this from F0. F0, which means our fan level is going towards 0. So between 0 to 10, you are mapping into 0 to 255. So let's make that 3. So you can see F0, F1, F2, 2, F3, 3. F4, 4, F5, 5, F6, 6, F7, 7, F8, 8, F9, 9. Add the last one, F10, 10. So you can see, so it will map this command there is mapping to this, which map to the PWM, that is speed. So now what we're going to do here will be for the DC fan. This is what we're going to do. It's equals to so we're going to make a sentence like this. So DC fan, we're going to do this. Now take note of this. You cannot combine an int with a string. You must convert the int to a string. So which is what I'm doing here. What is that int? Our PWM val. Okay, now we have two values which we are converting to string. The fan level, our fan level, we are converting to string. So take note of that. Then and then our PWM value. So you can see. So we'll now come down here and add it plus. You can see. So we have completed our this thing here. So now we're going to test this part of the program here. I'm going to upload this. Now let's do something here again. Let's move this down a little bit. Now this one is for turning on the bulb. You understand? Turn on the bulb, turn off the bulb. This one, turn on when we press, if you use F10, the fan will be in the highest speed. You are turning on the fan in the highest speed, and then F0, you are turning off the fan. So take note of that. But the fan, we are using speed level, but for the bulb you are not using PWM, and this is just digital logic, just high and low. You understand? So take note of this. You can see. So take note of this. So now if we give the command, let's say we want to turn on the fan and the bulb at the same time, we want a command that will turn on both the fan and the bulb at the same time. So this is what we're going to do. We're going to do something like this. Let's say, okay, let me just copy this. Let me demarcate this stuff so that we'll be able to separate them. Let me demarcate demarcate them so that we'll. So this one now, let's say if I type B1 F1, it means that I am going to do some now two things there. We want to turn on the bulb. You understand? We're going to turn on the bulb. So if I use B1 F1, that command is to turn on the bulb, and then I'm going to activate. I want my fan to run at the highest speed. So that's what this command is going to do. You understand? So this command that we have here, that's what it's going to do. Don't put here, I'll put it on one line. Okay, that's what this command is going to do. You understand? Turn on the bulb, turn on the fan, PWM at the highest, then copy it. So that if I have B0 F0, if I have B0 F0, what am I doing? The fan is going to off, the bulb is going to off. So we are using an advanced program, so you can see. So this one will be to your bulb on, then here bulb off. So you can see it. Then this one, bulb plus our bulb plus our fan on. So you can see. So that's what this is going to do. Then our bulb plus our fan off. So you can see that's what this one is going to do. Turn off our balance. So this one here is going to our fan off. So this one now will be our fan speed 1. So you can see that what it means. So I'm going to be our fan speed 2, fan speed 3, fan speed 4, our fan speed 5, fan speed 6, fan speed 7, fan speed 8, fan speed 9, and fan speed 10. So this is where the fan is in the highest speed. So you understand? So you can see that what this does. So you see now, so you can see our program. Now let's make something here again to give some indication that this is for the serial cable communication. So take note of that. So serial cable communication. You understand? So let's test this. Let's upload our code to check out for errors. We're going to upload this code, and then we're going to issue the commands to our board via the serial monitor, and then check our code correctly. So our code has fully uploaded. So let's go to our Arduino IDE serial monitor. Let's open our serial monitor. So I'm going to type B1 on our board. So you can see there my bulb is on. You can see B0 on my bulb. My bulb is off. So let's type F1 and see. Oh, our fan, you can see even the LED on my board, on the board there, is dimming. So let's say B1 again to turn on the bulb. Yeah, the bulb on my board is on. So and it's giving me reply the bulb is on. You can see the fan at the speed level 1 and the PWM 25. So let's say B0 F0. Oh, both the fan and the bulb is off. Let's say B1 F1. Oh, both. So you can see the PWM you are seeing there, it run at the highest speed what we did. So you can see how this is working correctly, perfectly. So you can see it. So let's turn them off again. B0 F0. So you can see the bulb and the fan is off. So let's say F2. That's the PWM, the speed here. F3. You can see the PWM, the bulb is increasing the brightness. F4. F5, enter. F6, enter. As you can see, F7, enter. F8, enter. F9, enter. F10, enter. The bulb is the LEDs are the full brightness. So you see, so our code is working perfectly. B1 to turn on the bulb. You see, so that's the F0. The fan is off. So you can see 0 PWM. Our system is working perfectly. You understand? It's working perfectly. So let's open it up again. So I'm going to capture its board using my phone. Where is our board? Okay, let me on my. I'm going to use my phone to capture it. So I'm going to issue command B1. You can see the bulb is on. You can see it. Our bulb is on. Then B0. Bulb is on. Our fan F1. F2. Increase the brightness. F3. F4. F5. F6, F7, F8, F9, F10. You can see. So the fan, the bulb, the LEDs, you can see at its brightness. So let me turn on the DC bulb. So you can see the DC bulb is on. So that the blue LED there, that blue LED there is indicating our DC fan, while the yellow, the red LED there is indicating our DC bulb. So to turn both of them off, B0 F0. So you can see that's very good. That's very good. So you can see them. That's very good. So turn them on again. B1 F1. You can see it. Then I enter. So you can see it. So we have successfully finished
controlling our board from our keyboard. So what we're going to do now, we have successfully tested our board, controlling it from the computer keyboard, controlling our board from the computer keyboard. You understand? Controlling our board from the computer keyboard. So we are going to do the part of the Bluetooth. So what we're going to do, we're going to copy all this. You understand? We're going to copy all this. All this, you're going to make a copy of it. You want to make the part of the side of the program, I mean the parts that will be controlling from the Bluetooth. So just copy it, come down here, you're going to paste it here. So paste it down here. Let's say Bluetooth serial communication. So you understand? So now this is what we're going to do. Let's come to the beginning of our program. Let's take note of this, our serial ports. So this first part of that, where we'll be able to control our board now, is from this. So we want to control our board from this, the Bluetooth, the serial. So what we are going to do now, we just add a BT. So we are just editing it. We are not changing anything there. We are just adding, we are just changing this to this. So that's what we are changing here. You understand? So this Bluetooth, that's your BT data. You understand? So BT data. So change everything you see here, serial data to BT data. That's just what we are going to do here. Just it. So if you are developing anything for Bluetooth, control it from your computer keyboard. If that works, then the Bluetooth will work. Because it's just exactly the same thing. So what here, we are just changing the name. You understand? It's just the same format, the same coding, the same thing. So the data type that we use there, so we are just changing it, switching it to this. So you can see, so which means we have two serial ports. That's your board will be listening to two serial ports, the cable connected serial port, and then the Bluetooth wireless communication also. So the serial port, that's the wireless serial port, which is the Bluetooth. So that's just what we just do there. So I'm going to upload it. Just as simple as that. So, and while I'm uploading this, take your Android phone, go to Play Store, and download Bluetooth serial port. So that's what we're going to do. So our code is uploaded. Now what I'm going to do, I'm going to take up my phone. I'm going to turn on my Bluetooth. I'm going to turn on my Bluetooth, and I'm going to pair my Bluetooth device. The Bluetooth module I'm using here is JDY30. So this thing is on now. So I've connected to my Bluetooth module. Let's okay, let me set it up. So I'm connected to my
So you can see some message information coming on my serial monitor. It's from my phone. So now my phone is connected to the Bluetooth module. Now I'm going to type in B1 from my phone now, from that serial monitor app now, my Android phone. I'm pressing enter. You can see I've just turned on the bulb on my board, and you can see the message on my serial. So let me send B0. You can see I've turned off the bulb. So let me enter F1. Here you can see as I'm controlling the PWM. Let me enter F10. The ISP, the bulb, the DC, the LED is full, it's in full brightness. So you can see. So let me type B1 F1. Sorry. So you see B1 F1, the DC bulb is on, the fan is at the highest speed. So let me use B0 F0. My bulb and my fan is off. So you can see. So I'm receiving the same reply on my phone also. So you can see how very easy it is good to use the phone to do this. So you can see it's very working very perfectly, working very well. So so we have done so we have successfully made our program, and it's working exactly the way we want to. So let's take a review of our program from the beginning. Now if you're writing any code, this is very important. We did all this, I've explained them. So all this, you can see your output pins. Now we're not going to, in this coding here with programming that we have done, the code that we have just written, we are not enabling our push buttons. It will be our second video where we'll be connecting our DC motor driver to the fan, then our relay driver to the bulb. That's where we are going to activate this button so that we can wirelessly or manually from push buttons operate our board. That means board nice. This fan and bulb now can be controlled in 3 ways: from computer, if it's connected to computer keyboard, or from our Android phone via Bluetooth, and also with push buttons. So for now we are not enabling these push buttons, and also the buzzer and this indicator within. So when we'll be enabling these buttons, so we're going to make beeping tones. So you can see. So we created a string variable to do this for our store the data coming from our serial, the cable connected to between the computer and our board, and then from wirelessly from the Bluetooth. Then our int variables for our PWM value and the fan level. Then our IOs, our input and the output pins, make sure you enable them. Then our 2 serial ports, the wired and the wireless, may give a little delay of 1 second. That's a delay for 1. That's what it means. So it doesn't leave delay. Then this is a welcome message on both the Bluetooth and the serial. So the void loop, this we have created a function, we call it here check the serial port. So to check if the serial is available, that is if there is data. So if there is data available, that's what it means. So if there is data available, do what? Read the data. Read the data.
till end of the line, or the end of message, or the end of the text. You understand? This is a string. You are reading the string, end of the string. The data is the form of a string, so read the data at the end of the string. So understand? So that's what that means. So send it back. Also know that you are actually receiving. So you can see, so two-way communication. So we use this command B1, B0 to turn on and off the bulb. For the fan, both the fan and the bulb, B1, F1, turn them on. B0, F0, turn both fan and bulb. Then this one here takes care of the fan speed levels. F0 off the fan, then down to F10, which is the highest. So you can see. So we just made a copy of everything we just did there for the Bluetooth, as you can see it. So you can see, so coming down here, PWM valve setup. We're going to map our fan level between 0 to 10, map it to 0 to 255, and then apply the PWM on the DC fan. So you can see, and then give reply feedback. So you can see. So let me scroll it from beginning slowly so that you take a good look at it. So in embedded system, takes the program, the coding part very serious. Take it very, very serious. Because if you cannot be able to write coding, it means you are not doing embedded system. So embedded system is software plus hardware. So you should be good in the coding. The hardware is very easy to do the hardware, but the coding parts, I advise you to get some C programming books, study them. It will help you in your Arduino C, because Arduino is based on C and C++. So that's all for this video. So we be doing our the second video, where we're going to be interfacing the DC fan and DC bulb. We are going to test it live, and you're going to see it how. So controlling something from your Android phone is something very so that's one of the essence of learning embedded systems, learning technology, to be able to make something, create things that will make life easy for you. You don't need to be moving around in your house to turn on the fan, come to sit down, then you stand up again, you go you go to turn it on again. But sitting in one place, you just take up your phone. So our Android phone had all these features that make it to become a remote control. So your Android phone now becomes a remote control. So you don't need to be stressing yourself, standing up and down to turn on the socket or the switch, the fan, or whatever it is. Any load, the AC or DC load that you're operating in your house. So you can apply this. So what you have learned here, you can add as many outputs as you wish, then control them from your phone. So here I've hooked up my webcam. Now we want to retest everything again so that you see it. I was able to hook up my webcam, my USB webcam, to my computer. So let's set our board so that we can see our I want you to have a clear view of my computer keyboard, and then my board. Okay, so I just wanted to have a view of my
Okay, let me set it correctly. I believe you can see the board very well now. You can see the DC fan and the DC bulb. Then look at my phone. So look at it. So you can see my phone here. Let me show you this is the app. You see, just open it and see how it is. So this is the Bluetooth terminal I'm talking about. So you can see, come down here, come to devices, but make sure you first of all pair your Bluetooth. So you can see my Bluetooth module here. I've already paired it. Make sure you pair it with the phone Bluetooth. Now if you buy any Bluetooth module, the password is usually 1234 if you have not changed the name on the password. So this is my Bluetooth module here. I've already paired it, so I will come to the app again, click on it. So you can see showing that it's connected. You understand? Now let's open I'm not going to use the Arduino ID serial monitor. I have a serial monitor program. You can see it here. My serial monitor program connected to my board here, where I'll be entering my commands. So now I'm going to enter on my computer keyboard. I'm pressing B1. You know, the computer keyboard is facing me, so it's facing me. The camera is just like the back. The keyboard is facing me. You understand? So you're going to see everything upside down on the keyboard. From the camera is at the top of the laptop screen. So I'm going to press B1. B1. You can see B1 here. So I'm going to press enter on my keyboard. You understand? So let me shift the camera so I see my enter key very well. So see my enter key here. I'm going to press it now. What do you see on the board? You can see the DC bulb is on. Then come to my Android app there. You are seeing message. You can see the message there. You can see. So let me turn it on my phone now. I'm going to turn the bulb off now. I'm going to type B0. This is B0 I typed on my phone. So I'm going to click this button, enter. So what do you observe now? The LED is off, and if you look at, you can see the reply on the serial terminal program on my phone there. You see it replying, and then also check on my serial monitor program on the computer. So you can see, so two-way communication. So let me control the fan now. So take a look at so I'm going to type I'm going to type F1. So F1. So I'm going to click the enter. So as I'm going to press the enter, then look at the LED. The LED, you can see it. You can see it. So you can see, let me hold the board to the camera so that you can see the LED very well. So you can see. So yeah, I'm with the phone. I'm going to say F. Let me press F5. Now just watch the LED as I press enter. You can see the brightness increased. So I'm going to enter F7. So I'm clicking my enter button on my phone. You can see the brightness increased. See F10 on my phone. I'm pressing enter on my phone. You can see that's the highest. You can see the LED very bright, the brightest. So you can see. So let me type F0 on my phone. You can see I'm controlling from my phone, and it's also messaging as you are seeing on the serial monitor on the computer screen there. You can see reply. So two-way communication. So now I'm going to turn on the bulb B1. So I'm going to turn on the bulb. You can see it. You turn on the bulb. Then F10, the fan. You see, bulb and the fan on. Then let's say B0, F0. Turn both of them from. You can see all I'm controlling from my phone. You can see it. So that's how you can use. Now, you see the serial terminal program on the computer. You can even customize. There are buttons on it that you can customize and be pressing them. You can see it has. You can even customize. It has buttons. You understand? So if you go through it is in very well. It has buttons. Let me show you something. If you want to install this, if you want to do the installation, let me turn on my data. Let me show you how you install it. Just go to Play Store. Go to Play Store. So once you're on Play Store, type Bluetooth serial or Bluetooth serial terminal. So let me show you. Look at it here. Look at it here very well. So this particular one, so you are seeing it. So that's the one that you install. What I've already installed it, so you can see it on my phone now very well. So you can see. So Bluetooth serial terminal. You see it. Bluetooth serial terminal. You understand? Bluetooth serial terminal. That's just what you just need to. So you install. That's how you install it on the phone. So you can see. So you can see that both from computer keyboard and now once you have, if you observe the Bluetooth, you can see the light on my Bluetooth module is not flashing again because it is paired to my phone. Now let me go to the app and disconnect. You see the Bluetooth on my breadboard will start to flash. Let me click on this button to disconnect. You can see it. I've disconnected. So click on this button again to connect. So once it's connected, you can see message, some kind of message coming up. So you can see. So that's how you can use Android phone to control your board. So this is not magic. If I can do it, you can do it. You understand? So whatever we can do, like from our computer keyboard, B1 F1 on my computer keyboard. See, on both and above. So you can see, so we have successfully controlled our I/O pins, our output pins, 2 output pins. You understand? 2 output pins, PWM pins from our computer keyboard. You understand? From our computer keyboard, and then from our Android phone. So you see, so our next video, we're going to be now that we have confirmed our code is working. Now the most important in embedded system, testing your code before you going for the final construction of the hardware. You must find a way of, so wow, LEDs are very, very important. This stuff, you understand? You can easily use them to test your code, your program. So you can say, so we have confirmed our program is working 100% correctly and perfectly, exactly the way we want it. You understand? Exactly the way we want it. You understand? It's working exactly the way we want it from our brain. Now, embedded system is just like transferring what you have in your brain to the brain of the microcontroller. So you can see the brain of the microcontroller. So what we think in our brain, we'll put it in writing, send it to the microcontroller's brain, telling it to do something physical. So that's what embedded system is all about. You understand? So go and try this. Add more outputs to yours. Now next time, in our next video, we are going to see this push button. We did not use them here. When we'll be interfacing our DC motor driver with the fan and the bulb, the real bulb, and then the fan, connecting it here, then we're going to enable so that we can be able to press the buttons, and then we're going to make our buzzer produce a beeping pattern when we press some of these buttons to also control it. So thank you. Stay cool and creative. If you benefit from this video, please share it, like it, and subscribe. Thank you. See you in our next video.